Hello, let's work on Lab 11. Use the tornadoes data and your statistical expertise to answer the question, is it reasonable to claim that the number of tornadoes in January will affect the number of tornadoes in August? Okay, so once you see this kind of question, then you need to go for the keywords. Just like here, the keyword is numbers of tornado in January will affect, right? The effect is the keyword in this case. So effect, one variable influences another, one variable causes another. That kind of, those kinds of keyword will certainly mean regression or multiple regression. So here in this case, since January will affect the number of tornadoes in August, so that's one variable affecting another. Okay, so that's why we would go for regression, right? So what test or procedure did you perform? So that's regression. Now, I hope you understood that. So one variable influences another is simply regression, right? Now let me download this data, tornadoes, all right, and then let me upload it. Okay, I have uploaded the tornadoes data, and let's see what the question is asking. Okay, so here question number 1, we have already done that. Question number 2, what is the relevant p-value or margin of error? So first of all, we need to say that number of tornadoes in January will affect the number of tornadoes in August. That means the number of tornadoes in January will be the x variable, which is the variable that is independent, and tornadoes in August is the dependent variable. Okay, so let's go for that. Number of tornadoes in January and August. So select January, okay, and then hold on Control key and select August. Copy it, Control C, and paste it in a new worksheet, Control V. All right. I will just simply throw away the excess rows. All right, looks good. And okay, so let's go for regression, right? Data analysis, and go for regression. Click on OK. Input Y range. Y range is the variable which is to be affected. So August is the variable which is to be affected by January. Okay, so that's August, and X, input X range is the independent variable which is January in this case. Okay, levels. Yeah, we have levels since we have this January as well. Okay, levels, and everything looks good, and click on OK. All right, so here we have our regression table, and let me just go for the p-value, since in regression we have p-values, right? So let me just highlight this, and okay, r square is also highlighted, and okay, intercepts and everything is highlighted. Okay, so this looks good. Now let us answer the question, what is the relevant p-value or margin of error? The relevant p-value is 0.922. 0.922. We don't have that over here. Okay, this is not the correct p-value. The correct p-value is always in this line. Okay, for the, you need to check the variable, x variable, which is January. Okay, so 0.922 is the p-value. Okay, which is not there now, so we are good. Okay, and we already know that 0.922 is greater than 5%. Okay, since 0.92 means that's 92%, which is a very big p-value. Big p-value means it's not good, right? So not a good p-value. P-value is not small. Okay, it's a very big p-value. So let us look at this statistical interpretation. Since p-value is very small, we are confident that the tornadoes in April will influence the tornadoes in August. No, that's not, since the p-value is not very small. P-value is not small, we cannot claim that the tornadoes in April will August. No, this is not the one. Okay, here I was just surprised by the answer, by this April month. Okay, since here it is talking about January, so no, we don't go for these two answers. Okay, since p-value is very small, no. Okay, none of these would be the thing. Okay. And is it reasonable to claim the number of tornadoes in January will affect the number of tornadoes in August? Okay, no, I cannot claim that the above assertion is reasonable, since we know that the p-value is very large, which is 0.922, so we cannot claim that the above assertion is reasonable. Okay, so that's it. Now let's go for task number 2. Task number 2. Let's read the question properly. Use the tornadoes data and your statistical expertise to answer the question. Is it reasonable to claim that years with more observed tornadoes in January would be the years with more overall tornado death? So here also it is claiming the effect of January to the overall tornado death. So the x variable is January and y variable would be overall tornado death. So you can see that in this original data, overall tornadoes death is January and total deaths would be this one. So you copy this two and paste it over here, all right, in the new worksheet. All right, and then you definitely know what I am going to say, since the question is talking about deaths in January affecting total number of deaths in the all the year round. So that means since one variable is affecting another, so it's regression, and you find the p-value. All right, so p-value would be simply, I won't be messing up around more, I will just go for regression and click on OK. So input to y range, y range is total deaths. Okay, so this is the thing. All right, and X range is this month of January, the total death in month of January. Okay, so that's it. Looks good. Click on OK. So then we get a new regression table. The p-value is simply this one. Here also p-value is this one. Okay, you can see the p-value January between January and all the death is 0.90. So 0.90. All right, none of this. P-value is very small, January influence, no, not small. We cannot claim that the number of January will okay, so this would be the best answer until now. So let's read other answers as well. Since p-value is very small, no, that's not it. Okay, so B is the best possible answer in this case. Okay, no, I cannot claim the assertion is correct. Okay, since the p-value is very large, we cannot claim that. Okay, task number 3. Use the tornadoes data and your statistical expertise to answer the question. Is it reasonable to claim that on average there are less than 25 tornado related deaths in the month of April? Okay, so here you can see that earlier in the case of regression we saw one variable affecting another, so we went for regression. Now in this case here the entire variable tornado related deaths in month of April is the variable, and we need to compare that with the average number 25, okay, are less than 25. So a variable to be compared with a number, then you go for confidence interval. Okay, so that's it. Now let's go for p-value or margin of error. Okay, p-value or margin of error. So let us go for the same data sets. So let's go for, okay, let me read the question properly. Tornado related in the deaths in the month of April. Tornado related deaths, it'd be this one. So let me copy this and paste it somewhere in the new worksheet. Okay, Control V. All right, in worksheet number 5. Okay, so this is tornado related deaths. Insert delete. Okay, that looks good. And here we need to figure out the margin of error. Okay, since we are going to figure out, we are trying to figure out the confidence interval. So to find out the margin of error, we write down the mean at first. So the mean is simply you just select the entire column, okay, and you look over here, the average is 27.35. Okay, so 27.35 is the mean, and we need to find the standard deviation as well. Standard deviation is equal to STDEV. Array is from A2 up to A47. Okay, all right, A46. Okay, looks good. All right, that's standard deviation. Okay, let me increase this. Okay, standard deviation is equals to STDAV A2 up to A46. Now we need to go for margin of error. ME. All right, margin of error is equal to confidence.t. Confidence.t. First of all, we need to have alpha. Alpha is simply 0.05. That's the default. Okay, 95% certainty. So 0.05 is alpha. Standard deviation is this number in D3, and comma size is how many are there. Okay, so there are 45, right? Okay, since from A2 up to A46 means there are 45. Yeah, so that's 45. Total rows are 45 rows of data. So that's the margin of error. So 18.21 is the margin. And now for confidence interval, let me just write down CI, and this first interval would be first number would be the left endpoint. Left endpoint is simply mean minus the margin of error, D2 minus D4. Okay, so that's the left endpoint of confidence interval. For the right endpoint of confidence interval, you write down equals to mean plus margin of error. So that's it. Okay, so confidence interval is from 9.13 up to 45.56. Okay, so that means, okay, so here what is the p-value or margin of error? P-value or margin of error is simply 18.21, none of this. Okay, the confidence interval is from 9.13 and 45.56, and it contains the number 25. Okay, so you so that's our statistical interpretation. The number 25 lies inside the confidence interval 9.13 up to 45.56. Okay, so statistical interpretation, since the confidence interval does not include 25, we are confident that the number of tornado related death is below 25. No, it's not correct, since confidence interval contains 25, right? So p-value is small, it's not talking about p-value. Since confidence interval includes 25, we cannot claim the number of tornado related death is below 25, since you can clearly see that in between 25 lies in between 9.13 up to 45.56. so the confidence interval is clearly saying that the sum of the tornado related death in month of April is slightly above 25 and below 25 as well. So this is the thing. Okay, all right. Okay, no, I cannot claim the assertion above claim is reasonable. So since it's partially correct. Okay, so let's go for task number 4. Okay, let's bear this thing. Okay, so here, so let us go for this task number 4. Your insurance company has converged for 3 types of car. Annual cost for each type of car can be modeled using the normal distribution with the following parameters: discussions allowed, car 1 type this one, car 2 this one, car 3 type this one. Use random number generator and simulate 1000 long columns for each of the 3 cases. For example, car type 1, number of variable 1, random numbers 1000, distribution normal 520, standard deviation 110, and so on. So let us go for new worksheet. Okay, and all right, so here what I will be doing is I'll just streamline the process so that it will be quite easy for all of us. So let's go to data analysis and go for random number generation. So random number generation, click on OK. So number of variables is 1. Okay, so we are going for car type 1, so number of variables is 1. Random numbers is how many do you want? 1000. Okay, so that's 1000. Distribution is normal. Okay, so distribution not normal. Mean is $520. Standard deviation is $110. Okay, random seed, put it empty, leave it empty, and click on OK. So that looks good. All right, and here in worksheet number 2, you write down type 1. Okay, car 1, simply car 1. Okay, that's fine. Okay, and now let us again go towards car 2. Okay, car 2. For car 2, you again do the same thing. All right, so go to data analysis, random number generation, click on OK. 1 and 1000, they are good. Mean and standard deviation should be changed. Mean is 720, standard deviation is 170. Okay, so that looks good. So then this worksheet 3 is car 3. Okay, car 2, sorry. Okay, and for car 3 you again do the same thing, data analysis, random number generation, click on OK. That is 470 and this one is $80. Okay, click on OK. All right, so this is car number 3. All right, looks good. Now, since this would be a tedious question, as I mentioned it earlier, so here, first of all, what we do is we simply sort the data for car 1, car 2, and car 3. So let us sort the data. So that would be just highlight it. Okay, highlight the entire row, entire column, I mean, and sort smallest to largest. Okay, so let's do that. Okay, so for car 1 we have sorted it out. For car 2 you sort it out smallest to largest, right? And car 3 you sort it out, right? Highlight it and sort smallest to largest. Okay, looks good. All right, then here it says that what is the approximate probability that car type 1 has annual cost less than 550. Okay, car type 1, so car 1 has annual cost less than 550. So to do this question, you just go to car number 1 and find out $550. Okay, so Control F, right? Find 550. Okay, so 550. First of all, it is highlighting this one. No, it's not that. All right, let us go down. Okay. All right. So less than 550 means you can see that the 614th in the 614th column row, sorry, in the 614th row we got $550 as the maintenance of the car. So all 613 cars cost less than $550. Okay, so 613 divided by 1000. So that's our probability, okay, which is simply 61%. Okay, so that's 61.3% is the probability that car of type 1 will have maintenance cost less than 550. Okay, so this one between 55% and 70%. Okay, so that's fine. Which of the 3 types of car is most likely to cost more than $1,000? Okay, more than $1,000. So for this one, let us first go for car 1. Car 1, let us find out $1,000. Okay. Okay, for $1,000, why it is not doing so? Okay, for you can just simply go for you can just scroll down and find $1,000. Okay, I don't know why it is not showing up. Okay, so here for car of type 1 we don't have a value, so that's why at the Control F, that dialog box didn't work. Okay, so none of the car. Okay, so 0% probability for this one. 0% probability for car 2. Let us find out $1,000. Okay, Control F. Yeah, $1,000. No, it also doesn't do that. So that means I don't think we have. Oh, okay. There are several cars which has more than $1,000. Okay. So 949, yeah, you just once you find $1,000, okay, since the question is asking you more than $1,000 means you just go for this 1,002 and just select all the numbers which is above $1,000. Okay, so that means there are 52 of them. So 52 equals to 52 out of $1,000. Out of 1,000 cars. Okay, so that means there will be 5%. Okay, 5.2%. 5.2% possibility that the annual maintenance cost will be more than $1,000. Now let's go for car 3. Here also let us figure out more than $1,000. Okay, car costing more than $1,000. No, it doesn't have that. Okay, so here also 0%. Okay, So 0%. So you can clearly see that car 2 has the highest probability that it will cost more than $1,000. So car 2, type 2. For which of the three types of car we have highest average cost? Highest average cost is simply car 2, right? That's it. You don't have to go to the data. Okay. Highest average cost is type 2. Okay, that looks good. Okay, so that was quite tedious. Now let's go to tutorial. I don't think I'll say anything about tutorial. We'll just simply do the things, okay, do the problems. Okay. So task 5 here. Use the previous tutorial. Address the following. Imagine an experiment where 3 dice are tossed and the numbers on each dice are recorded, die 1, die 2, die 3. Answer the following question and about the sum of 3 numbers recorded from 1, 2, and 3. Okay. So here, simulate this experiment 1,000 times. So we need to roll the die for many times. Okay. So here, first of all, let us go to the data. Come on, let us come up with a new worksheet. And since we are working with the probability and we are rolling a dice, so that's why what we need to do is we need to go for output. We need to come up with a probability table, okay, and probability. Let me just write that down. So output is 1, 2, 3, 4, 5, 6 for 6 sides of a dice, okay, equals to 1 over 6, right? Okay, since 1 over 6 is the probability of each of the face of the die, so that's it. All right, once we have done that, then let's go to data analysis, okay, and go for random number generation. Click on OK, and here we want discrete distribution, okay, since we want value and probability input range. So for value and probability input range, okay, you just click over there and go for select the output and probability. Okay, so that's it. Oh, look here, I should not select A1 up to B7. Instead I should select A2 up to B7. All right, don't use the labels. Okay, and we know that in the question it is saying that we need 3 dice, right? So for 3 dice we need to go for three variables, since we want 3 columns, and random numbers 1,000. Okay, we want 1,000 trials. Okay, so click on okay, so everything looks good. All right, that looks good. So we have 3 columns of data with 1,000 of them. Control N, yeah, there are 1,000 of them. So that's it. All right, now let's see what it is saying. Answer the following question about the sum of the 3 numbers. Sum of the 3 numbers is die 1, die 2, die 3. Okay, die 1, die 2, die 3. Let us sum these things. Okay, equals to sum, right, from A1, B1, C1. Okay, let us add them up. Okay, so that's sum, right? So you just double click the right bottom and everything will be populated. So just go to the end. So that's it. All right, so first of all, figuring out what is the probability that all right, so now finally create a histogram based on this new column. Since we know that there are 3 dice and we have rolled them, so the least possible number would be 1, 1, 1 for all of these dice. So the the beans would be starting from 3 and we go all the way up to 18. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so these would be the numbers of bins. So then let us go to data analysis. Let's go for histogram. Click on OK. All right, input range is D1 up to D1000. Okay, so here what I did is I just don't want to scroll all the way down. I just selected D1 and just scrolled few steps down and just change this D9 to D, just backspace, and 1000. Okay, since we know that there are 1000 number of data, 1000 number of rows. Okay, bin range is simply just click over there. We know that bin goes from E1 up to 16. All right, so that looks good, and we don't have labels, so click on OK. So that's our frequency and bin and frequency. Okay, it looks good now. If you are fancy enough and if you want to look at the histogram, then you just click, you just copy this, select this, and insert the histogram. Okay, so recommended charts, yeah, you go for this one, click on OK. So looks good, free bins and frequency. Okay, that looks fine. All right, now here it is saying that what is the approximate probability that D1 plus D2 plus D3 equals to 10. Okay, 10. Okay, what is the approximate probability that you will be getting 10? So that's 125 divided by 1000. Okay, since there are 1000 dice, the 3 dice was rolled for 1000 times. Okay, so 0.125, that means 12.5%. Okay, 12.5% is approximately near to 10%. Okay, it's close to 10%. What is the approximate probability that die 1, die 2, die 3 is greater than 10? Now, greater than 10 means you want all of these things, right? This one. So highlight B10 up to B17. If you highlight B10 up to B17, then you will get the total sum, which is 494. So 494 divided by 1000. Okay, and don't forget to put a equals in front. So that's it, 0.494. So that's nearly 50%. Okay, so that's 50%. What is the approximate probability that die 1 and die 2 will be greater than 9? So in this case, we need to create a new chart. Okay, so new table. Let me just delete these two. We don't need this thing, so delete them. And now let me delete this as well. We don't need this one, right? So here, let us sum this thing. Since we won't be using anything, so I have deleted everything else. Sum A1 B1. All right, this looks good. Okay, and then you just hover on the right bottom, and until you see that black plus sign, then double click with your left mouse button, then everything gets populated. You can see. All right, and now bins would be simply 1, 1, 2 up to 12, right? Since 1 and 1 would be the least numbers that can appear in a die. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that looks good. Now here again, let's go to data analysis and go for histogram. Click on OK. D1 up to D1000. No, that's C1 up to C1000. Okay, so that's C1 up to C1000. All right, and bin range is simply D1 up to D11. All right, levels, we don't have levels. Click on OK. All right, looks good. Okay, and then now if you want to draw a histogram, then go for it. I don't think we need, but if you want that, then you can clearly see how does it look like. Okay, so this looks fancy enough. All right, and it is saying greater than 9. Okay, what is the probability? We have greater than 9. So that means greater than 9 means we need to go for 10, 11, and 12. So their frequencies are 84, 55, and 30. So if you select them, then you'll get the sum, which is 169. So equals to 169 divided by 1000, since there were 1000 trials. So 16.9 or 17%. Okay, which is close to 15%. That's it. All right. That's all for task number 5. Task 6. Okay. Is it reasonable to assume that average hurricane pressure for category 4 is different from category 1? Given the data, your job is to check if this assertion is reasonable or not. Hint, read lecture 24. What would be the correct null hypothesis? First of all, to figure out what is null hypothesis, we need to read the question carefully. Is it reasonable to assume that average hurricane pressure for category 4 is different from category 1? So this statement reminds us of two-sided t-test. It is trying to see whether the averages are different or not. Okay, so that's why we go for two-sided t-test, right? So that's why we go for, since we are trying to see the difference, so the null hypothesis would be the population averages are equal. Okay, the p-value is this much, 3.33 to the power e to the power negative 0.9. That means it's a very small p-value. So we reject the null hypothesis. Okay, one line additional comment. we cannot conclude that the idea between two categories are related. It's not that. We are confident that hurricanes with category 4 has different pressure than that of category 1. That's it, since the p-value is very small, right? So that's all. So that's it for lab number 11. Okay, see you.